Hey everyone, so this is lesson 1 for unit 10. This is going to be talking about systems of linear equations. Now, I'm going to show you how to do the first do now, just so that you kind of get a refresher. But recall that we talked about this in previous unit where we have 2 variables and 2 unknowns. So the way we're going to do this is we're going to take these 2 equations and either add or subtract them in order to get rid of a variable. Now, I'm going to do number 1. So we can actually see right off the bat that we have a plus 2y in the first equation and a negative 2y in the second. So if I add these 2 equations, I can get rid of the y. If I didn't have that case, I would have to multiply the second line by something so that I can get rid of it. So going through, 4x plus 2x is going to be equal to 6x. 2y plus negative 2y is just 0. And then 22 plus 8 is 30. Once we get this, we get we can divide both sides by 6, and we get x equals 5. Once we get what x equals to, we could take one of the other 2 equations, plug 5 into it, and solve for the other variable y. So I plug 5 in, 2 times 5 is 10, minus 2y equals 8. Subtract the 10 over, and we get negative 2y equals negative 2. Divide both sides by negative 2, and I get y equals 1. I'm not done yet because once I do this, I then have to double check by plugging these numbers into the other equation. So I didn't use the first equation before, so I'm going to use it now. So 4 times 5 is 20. 2 times 1 is 2. 20 plus 2 is 22, which is what we get up here. So this is correct. So remember, this is what we talked about before on how we can solve 2 linear equations with 2 variables. Now recall down here, what this means graphically is that if we were to take those 2 lines, put them on a graph, that x and y value would identify where 2 lines cross. Now in Algebra 2, we did a system of 2 linear equations, 2 variables. Here, we're going to be doing 3 equations with 3 variables. So graphically, it says, what do you think x, y, and z identify? So, try thinking about this yourself. Now, in this case, instead of 2 lines crossing, this is actually going to be 3 planes crossing. So there are a few different cases. There's the case where we have 1 or more solutions. So this basically means that they all cross at shared points. So that could be either they cross one time, all at the same location, or maybe they cross along an infinite number of points. And then no solutions mean they don't all cross at shared points. So they may cross, but they may cross at completely different points. I highly recommend that you watch this video. I'll link that as well, as it gives a very good visualization of everything that is going on with crossing lines and all that. All right, so how do we do the 3 linear equations with 3 variables? Well, our first step is we have to pick 2 pairs of equations and try to get rid of one of the terms. So what I'm going to do is I'm actually going to pick equation in this guided practice. I'm going to pick equation number 1 and equation number 3. Now, it doesn't really matter which equation you pick, but some equations will make life a little bit easier than others. In addition, the second pair that I'm going to do is I'm going to pick 2x plus y plus 3z. So the second equation, and I'm going to pick the third equation again. So one of the equations in the pairs is going to be repeated. So from here, now, just like we did last time, we have to find a way to get rid of the same variable. Now, the variable I'm going to get rid of is x. So in order to get rid of x, I need to multiply the second equation by 4. So everything in this second line is going to get multiplied by 4. So this negative x becomes negative 4x. The 2y becomes 8y. The 5z becomes 20z. And the 17 becomes 68. Because this is negative 4x and the top is positive 4x, I'm just going to add them. So 4 plus negative 4 is 0. Negative 3 plus 8 is positive y. Let's get rid of that positive. Positive z plus negative 20z is negative 19z. And then negative 10 plus 68 is going to be 58. Over in the second pair, I'm going to do the same thing. I have to get rid of the x, so this second line has to be multiplied by 2. So this becomes negative 2x. The 2y is now going to become 4y. The 5 is going to become 10. And the 17 is going to become 34. So once again, I add these two. 2 plus negative 2 is going to get me 0. Y plus 4y is going to get me 5y. 3z plus negative 10z is going to get me negative 7z. And 0 plus 34 is 34. Now, if you look up here, we just completed step 2. Now step 3. Step 3 is basically taking these two equations we just got and doing what we did in the do now. So this is step 3. I'll do it a different color. So I'm going to take the 5y minus 19z equals 58, and 5y minus 7z equals 34. Now, in order to get rid of here, I actually can see that I have a 5y in both equations. So it really helps for me to subtract them. And just to make my life easy, I'm going to distribute the negative to all terms. So negative 5, the negative 7z becomes a positive 7z, and the positive 34 becomes a negative 34. So again, now I'm going to add them. So 5y plus negative 5y gets me 0. Negative 19 plus 7 is going to be negative 12z. And 58 minus plus negative 34 is going to give me 24. Solving for the z, divide both sides by 12, and I get z equals negative 2. Now, just like with the do now, once I get this negative 2, I go back to my original one of my new equations, plug in the z that I just got, and solve for y. So negative 19 times negative 2 gets me positive 38 equals 58. Subtract the 38 from both sides. I get 5y equals 58 minus 38, which is 20. Divide both sides by 5, and I get y equals 4. So I now have a y value and a z value. I can now go to step, I'm going to go to step 4, where I substitute my y and z back into one of these 3 original equations. Doesn't matter which one I pick. I'll pick the negative x one. So y was 4 and z was negative 2. And let's solve for x. So we get negative x. 2 times 4 is 8. Negative 5 times negative 2 is plus 10. Negative x 8 plus 10 is 18 equals 17. Subtract the 18 over, and I get negative x equals negative 1. Divide both sides by negative 1 to get rid of the negative in front of x, and I get x equals 1. The very last step, change the color once again, we'll do blue, is check the solution by taking these numbers and putting into one of the other two equations. So I need to pick one of those two. Again, doesn't matter which one. I'm going to pick the 2x one. 2x plus y plus 3 times z equals 0. So let's check to see if we get this, this answer. So 2 times 1 is 2. 4 is just by itself. 3 times negative 2 is negative 6. 2 plus 4 is 6. 6 minus 6 does equal 0. Therefore, our solutions are correct. So my answer is x equals 1, y equals 4, and z equals negative 2. And that's pretty much it. So it does seem like it's a lot of work, but it's a lot of the same work that you're repeating. So as long as you make sure that you practice and you go through the same thing, it shouldn't be too difficult. Now, I'll give you a little bit of a tip on the independent practice. If you look at this, so my big recommendation, you can do whatever you want, but I always recommend choosing, finding the variable that is by itself and using that to get rid of the other choices. Here, the y is by itself. So my recommendations for the two pairs would be 3x minus 2y plus 7z equals 5, and then 2x plus y plus 3z equals 10. And then the other one would be 3x plus 3y minus 4z equals 7, 2x plus y plus 3z equals 10. And you would solve these to try to get rid of the y term. So you'd multiply them by whatever number to get rid of the y in the first pair and then the y in the second pair. All right? So I'll leave the rest up to you. If you have any questions, please let me know. Otherwise, have a great day.